7.6 Properties of Metals, Nonmetals, and Metalloids. Metallic character increases to the left of the periodic table and down our groups. We should note that metals are to the left of the staircase, nonmetals are to the right, and metalloids are along the staircase, in this image in purple. Metals versus nonmetals. Metals have a shiny luster, various colors, although most are silvery in color. They are solids and malleable and ductile, good conductors of heat and electricity, and most metal oxides are ionic solids that are basic. We'll talk about those reactions momentarily. They also tend to form cations in aqueous solution. Nonmetals do not have a luster. They do come in various colors. The solids are usually brittle, some are hard, some are soft. Poor conductors of heat and electricity. Most nonmetal oxides are molecular substances that form acidic solutions. Again, we will talk about this reaction momentarily. And they tend to form anions or oxyanions in aqueous solution. The differences between metals and nonmetals tend to revolve around these properties.
Most elements of the periodic table form at least one oxide. The oxides of the representative metals are ionic in character. They dissolve in water to form basic solutions. The oxides of the nonmetals are generally covalent in character. Many of them react with water to yield acidic solutions. Many nonmetals form more than one oxide. In general, the acidity of the acid formed from the oxide increases with increasing oxidation state of the nonmetal. For example, sulfur forms two common oxides. Sulfur dioxide, in which sulfur is in the +4 oxidation state, and sulfur trioxide, in which it is in the +6 oxidation state. Sulfur dioxide reacts with water to form sulfurous acid, H2SO3, a weak acid. Similarly, SO3 reacts with water under appropriate conditions to yield sulfuric acid, a strong acid. In summary, the oxides of the strongly metallic elements form basic solutions, while the oxides of the nonmetals generally form acidic solutions. The oxides of many other elements may exhibit either acidic or basic character and are said to be amphoteric. The acid-base properties of transition element oxides must be discussed separately.
Metals tend to form cations. Nonmetals tend to form anions. Metals tend to lose valence electrons. Nonmetals tend to gain valence electrons. Metals tend to be lustrous, malleable, ductile, and good conductors of heat and electricity. Compounds formed between metals and nonmetals tend to be ionic. Nickel oxide does not dissolve in water, but does react with nitric acid to give a green solution of nickel nitrate. Metal oxides tend to be basic. Sample exercise 7.8, metal oxides. Would you expect scandium oxide to be a solid, liquid, or gas at room temperature? Write the balanced chemical equation for the reaction of scandium oxide with nitric acid. We are asked about one physical property of scandium oxide, its state at room temperature, and one chemical property, how it reacts with nitric acid. Because scandium oxide is the oxide of a metal, we would expect it to be an ionic solid. Indeed, it is, with a very high melting point of 2,485 degrees Celsius. In its compounds, scandium has a +3 charge. The oxide ion is -2, consequently, the formula of the scandium oxide is Sc2O3. Metal oxides tend to be basic, and therefore to react with acids to form a salt plus water. In this case, the salt of scandium is scandium nitrate, and the balanced chemical equation shows us the metal oxide reacting with nitric acid, forming a salt and water. Practice exercise. Write the balanced chemical equation for the reaction between copper-2 oxide and sulfuric acid. Nonmetals. These are dull, brittle substances that are poor conductors of heat and electricity. They tend to gain electrons in reactions with metals to acquire a noble gas configuration. Substances containing only nonmetals are molecular compounds. Most nonmetal oxides are acidic. The reaction of carbon dioxide with water containing a bromothiamyl blue indicator. Initially, the blue color tells us the water is slightly basic. When a piece of solid carbon dioxide, dry ice, is added, the color changes to yellow, indicating an acidic solution. The mist is water droplets condensed from the air by the cold carbon dioxide gas. Sample exercise 7.9, non-metal oxides. Write the balanced chemical equations for the reactions of solid selenium dioxide with water and aqueous sodium hydroxide. We first note that selenium is a nonmetal. We therefore need to write a chemical equation for the reaction of a non-metal oxide, first with water and then with a base, sodium hydroxide. Non-metal oxides are acidic, reacting with water to form an acid and with bases to form a salt and water. Selenium dioxide is SeO2. Its reaction with water is like that of carbon dioxide. So when selenium dioxide reacts with water, it will form, an acidic solution. It does not matter that selenium dioxide is a solid and carbon dioxide is a gas under ambient conditions. The point is that both are water-soluble non-metal oxides. The reaction with sodium hydroxide is like the reaction summarized by equation 716. We have a non-metal oxide reacting with a base, so an acid plus a base yields a salt plus water. Practice exercise. Write the balanced chemical equation for the reaction of solid tetraphosphorus hexoxide with water. Metalloids. These have some characteristics of metals and some of nonmetals. For instance, silicon looks shiny but is brittle and fairly poor conductor.